In this video, we will discuss about how to represent binary tree in class. So, in program, how will I represent tree? So, let's take one tree. Left is 1, right node is 2, 3, 4, 5. So for representation in class, first we need node. One node class we need for representation of binary tree. So previous video I have already discussed, in a node there are three properties. One is data, left pointer and right pointer. So here data is 0 and suppose there is a, for one address is address. Here in left pointer there is a address of memory. So suppose left pointer is in 400 address, and here right subtree is in 300 address. So now, so here data is 1 and suppose left node is exist in 500 memory and right node is exist in 600, right? So now one left node is 3, so node is 3, and suppose here left node and right node is nothing, means left and right child is not available here, so address is null, right node pointer is null, means it's leaf node. If you want to know more about leaf node, what is the label, what is the root, I will recommend you please watch my previous video. That video title is Introduction of Tree. Means when our left pointer and right pointer will be null, it means that is leaf node. So you can see here 4 and right is a null. Now this is the root. So here data is 2 and suppose left child address is 700 and right child address is 800. Now this will point to 5 and left and right will be null. So data and left and right pointer will be null. So in this way we can represent binary tree. So first we need data. So data, first we need node. So I need to write node class. Node. In node there are three properties. One is data and second is right pointer address, and first is left pointer address and second is right pointer address. So I will put here data. So left pointer data type is node. Node right. I will call one constructor. So whenever I will put here new node 0, so when I will call this one new node, this constructor will be called. So it will take data, means when you call here node 0, it means you are calling, it means we want one node whose data is 0 and left and right is null. So we want to create one node. So when we write this, when we write like that, so it means we are calling constructor. So when we call this constructor, we will initialize this value. We will initialize this value from this value. Whatever passing from this function, we will initialize here. So first we will, when we call this constructor, when we call using 0, then on that time we are inserting here 0 data, and the left and right will be left and right we will set null. Later on we will set left and left reset. Later on we can reinitialize the left and right with some node value. This is the node class. Now node class we need in binary tree class. So now we are representing, means we are representing binary tree in binary tree class. So in every tree, first we need root. So here I also need root. Now here I am creating one function. That function I will call from in next, means any tree video I will call this function, and that function will give binary tree object. Means this binary tree will give, means one I will create one static method, and that static method I will call from in next video where we will use tree. I will call this function, I will call this binary tree, whatever function I am writing here, I will call this function and it will give this binary tree. So here I am calling, I am creating one function, and that return type is binary tree. Binary tree. So what we have to do, first we have to initialize this value. Root we have to initialize, so root is 0. Then what we have to do, first we have to create one object, that is binary tree object. That would be the return type btree. Btree means short form is binary tree. Binary tree. Now I have created this root, I am initializing here, and after that we are setting this root in this object. So you can write here binary tree dot root equal to new node 0. Now root I have created. Now I have to create, when means first time when I initialize root, then left and right will be null. Now this left part I have to reinitialize with this two node, left and right children. So binary tree dot root dot left, I have to create one new node that will call the node constructor, and it will give value is 1. So value is 2. So as of now what we have created, we have created root, and after taking root node, this left pointer and right pointer I have initialized with this node and this node. We have created root. When we created root first time, it was null value. Then again this null value I have initialized with this node, reinitialize with this node, and right value will initialize with this node. Now I have to this left and this right as of now is null. So this left and right again we reinitialize with these two nodes. So binary tree dot root dot left right, binary tree dot root dot left. So we have to initialize 3. Right dot right equal to what is the node 4. So right child is 4. Right. Now this part root 2 here I have created and this left. Now these two nodes has left. So this node again we have to reinitialize with, as of now this value and this value is null. So this null I will reinitialize with this node, and this right null will reinitialize with this node. So root dot right dot left equal to new node, and that is 5. Right dot root dot right equal to new node 6. So here we have to binary tree this object I am initializing, and we need to return after setting all value of node, means all node data after setting we need to return binary tree object. So for that purpose we have created binary tree object. Now I will return binary tree. So this functionality, so this function will give, this function will not take any argument, and this function when I call this, we are creating a static function. So when I call this binary tree dot get binary tree, it will provide binary tree object, means this binary tree will be provided. We can write here main program, main method, and I will call this I will get this binary tree object using a static method binary tree dot get binary tree. So I will get this binary tree object. So in this way we can create binary tree. So if you execute in next video, if you execute any program related to true, I will call this functionality in on those classes I will use on those classes I will use only this one, means I will create one binary tree object and I will call this get binary tree, and it will give binary tree. After taking binary tree, whatever we need to do, either traversal or anything we have to do, we can do.